Hello, in this video I'm going to introduce you to carboxylic acids, which is part of organic chemistry. From the AQA specification it's 4.7.2.4. So carboxylic acids have a functional group, has a carbon with two oxygens and a hydrogen, or a Q group. What you've got is carbon bonded to something, and then you have a double bond to one oxygen, single bond to a second oxygen, which then has a hydrogen bonded to it. The formation of carboxylic acids is by the addition of something called an oxidizing agent to any alcohol. So let's say ethanol, probably the most famous of all the alcohols. Oxidizing agent is square brackets with an O in it. You don't need to know that for GCSE. I'm just, it's shorter to write that than oxidizing agent. So you take ethanol, you add an oxidizing agent to it, and you get eth, and the name for these functional groups is always enoic acid. So ethanol to ethanoic acid. If I'd given you propanol, propanoic acid. So I've drawn out the functional group for the first four of these. If you want, please pause this and see if you can figure out what the names are. And then check that you got them right. So I'm going to go from 1 down to 4. The first one is methanoic acid. The second is still ethanoic acid. Hopefully you remember MEPB, or my elephant proposed beautifully, because that takes us to propanoic acid. And finally butanoic acid. And honestly, right now, this is a point when you're better learning this virtually. Butanoic acid smells slightly like a cross between vomit and rotting meat. Be really, really glad that you do not currently have a bottle of this open in front of you. Ethanoic acid, on the other hand, is one that you will have come across in your kitchen because that is the main part of vinegar. So, every one of them has this Q group. Meth, one carbon. Well, there is one carbon here, there will be nothing else. So we know we have to get 4 bonds for every single carbon. We have 3, so simply put, one hydrogen, and there you've got it. For ethanoic acid, one carbon already. The F tells us 2, so put the extra carbon in here. This carboxylic carbon has 4 bonds already, there'll be nothing else. We add in the second, third and fourth bonds to our carbon here, and we fill them up with hydrogens. So when we're writing the formula, you always finish it as a COOH, and for the first one, for methanoic acid, we just put the H in. For ethanoic acid, we write our Q, and then we take this part here, and we write CH3. Again, please pause the video now and try and do the next two yourself. Welcome back to those of you that went away. Shame on you for those that didn't. One carbon here. Prop tells us there's going to be 3. So I'm drawing my second and my third carbon in. This again has all the bonds it needs. So the other ones, we take them, so they've always got 4 bonds. 4 bonds for every carbon, 2 bonds for every oxygen, and 1 bond for each hydrogen. So 3 carbons, but don't write C3, because remember you separate the COOH, so it's C2H5. Do again, pause and check out the last one if you can. I'm drawing this at an angle, not because that's how you should do it, but because I didn't leave enough space. There's nothing better for it than that. 3 carbons to the 1 original one there makes the 4 for but. Every carbon gets 4 bonds, filling them up with hydrogens, so C3 with H7 and COOH. So that's the first thing you need to know, the formula and the name. You need to be able to recognise these 4. They continue after this with 5 carbons with pentanoic acid and then hexanoic, but they just want you for AQA to know these ones. So know what your functional group is, know that they were formed from alcohol, and you've got the first part of this. The second part, smooth. The second part of the topic is that we need to know what happens for the reactions of carboxylic acids. And there are 3 reactions that we can do. The first one is a very easy practical, you're not missing out on much. We could give you a bottle of, say, ethanoic acid and ask you to add it to water, and the remarkable thing that you would observe is that they dissolve. That's it. So what you need to be able to do is describe what would happen if any carboxylic acid was added to water. For one word, they dissolve. If you want to go and have a look in your kitchen right now, you will find that there will be some vinegar likely, probably. I mean, it's lockdown, there might not be any more because you've run out of everything. But nonetheless, vinegar is water and ethanoic acid dissolved in each other. Moving on, alcohols. We would do this reaction in lessons, and it is unfortunately one of the best practicals ever, because the thing that they make, carboxylic acid with an alcohol, it's the 5th family of chemicals that we would learn about. They are called esters. We don't really need to know very much about them other than they exist. There's also a byproduct, which is water. These smell great. They are used for flavourings and they're used as perfumes. So if you've ever eaten particularly fruity flavours, sweets that you bite into and you know that there's never been an actual piece of fruit anywhere near the thing that you're eating, it's probably got one of these esters that has been created in a laboratory. So please don't go and try this in your kitchen by adding some vodka to some vinegar, because you need to have essentially the pure chemicals, and you do need a catalyst to lower the activation energy and provide an alternative route that way, and you would need to heat it as well. Please don't try this at home. You don't have to know the names of any esters except for one, and that's the one where if you reacted ethanol with 2 carbons with ethanoic acid, and you do need to make a note of this name here, you get a chemical called ethyl or ethyl ethanoate. Eth from one and eth from the other, and yes, you get water. So I've drawn these 2 chemicals out below. Hopefully you still remember that the reactive part of the alcohol is the OH bond, and that is in fact the bit that we break. So I have not left enough space to the right, so I'm going to do this down below. The CH bonds and the CC single bonds, you know that they don't change in these reactions. They are unreactive. Carbon-hydrogen single, carbon-carbon single, unreactive. The reactive bond here was the OH, so I've broken that, I've taken the hydrogen off. Now this byproduct is water, H2O. If I take away the hydrogen here, to get water, I need another OH. And so that leaves me with just this part of the molecule here, where there's the carbon with the double bond, and so that is our new molecule. This, if I cover one side of it, you can see it looks just like the carboxylic acid above, and if we cover the other side of it, you can see it looks just like the alcohol. So this is an ester, and they are very good smelling, sort of fruity chemicals that you can actually eat. Some of them. Please don't try making them at home. Right, the third reaction series that you need to know about is metal carbonates. Carbonates are CO3 2 minus ions. So the formula of calcium carbonate would be CaCO3. You don't have to do balanced equations for these. You've just got to try and remember that you saw carbonates in the paper 1 topic of acids. You can, if you seek parents' permission, try this experiment, or you can go to YouTube. Ethanoic acid is vinegar, and if you Google vinegar and baking powder, baking soda, you'll get a combination of carbonates that people can react with this. You will see one thing above all else. You will see lots and lots and lots of bubbles. So I need you, when you see carbonates, to be thinking about bubbles, and hopefully from the carbon you remember that it's going to be carbon dioxide. So that's one of your products. The next one, when you do acid and base reactions, you get the neutral product, so it's going to be water. Any time that you get a carbonate with an acid, carbon dioxide and water, and what you're left with is a salt. So that's where the metal is going to go. So this will be calcium. That has to end up somewhere, and the other part comes from the acid here, so that will become calcium. And you change the name very slightly to ethanoate, which would be in the same way that if you had sulfuric acid with calcium carbonate, you would get calcium sulfate. So I'm going to give you another one to try here. Please do pause and give it a try. Propanoic acid, you can see I've just changed the number of carbons from above, and rather than doing calcium carbonate, let's pick another metal. Let's do sodium carbonate. So please pause this, give it a try yourself, remember what happened before. 3 products, give it a shot. Okay, hopefully you kept thinking about the bubbles, and you know from carbonates you get carbon dioxide. You know that you are going to get the neutral product of water, and then you're requiring a salt, so you take the metal, the first part of the salt, so in this case it's sodium, and we're going to change the name very slightly from propanoic to propanoate. Okay, thank you very much for watching.